Hi, my name is Josh Taylor, Master Service Technician with RapidView. Today on RapidView U, we'll be showing you how to reterminate a pushrod cable. One of the first and most important things that you need to do before you reterminate your pushrod cable is to determine where your cable damage is. Here's a very common example of some cable damage that can happen to a pushrod cable. Inside of here, there's a fiberglass rod, and then there's all kinds of circumstances that can happen while you're using your pushrod cable that'll cause this rod to break. So if the rod breaks, then it's not going to allow you to effectively push as well. So this is a good reason to get a retermination done. Secondly, you can lose your video image, or sometimes your video image can become intermittent. To test for this, you can flex this end around with a camera attached with the system turned on. And then if your video cuts in and out with the movement of the cable, you need to have a retermination done. Once I've determined that my pushrod cable needs a retermination, I'm going to remove the damaged section of my cable. So I'm just going to take some cable cutters with the system powered off and remove the damaged section of cable. So as you can see, this is the end of the cable I've cut off. The damage has been removed from the remainder of the cable. Next, I'm going to cut off so I have just the end of the cable to work with so I can disassemble it. For disassembling your pushrod connector, the first thing you're going to want to do is remove the sleeve nut at the back. To do that, I'm going to use a normal pair of slip jaw pliers and a 19mm wrench. The next thing is to remove the hose coupling assembly. Once these 3 screws are removed, the rear portion of the hose coupling assembly should slide off. Your spring will come off next. I'm going to use my cable cutters to remove the front portion of the pushrod connector, leaving the remainder of my hose coupling. This comes apart in 2 sections. You should be able to get it apart with a screwdriver. I'm going to take a 14mm wrench and use this to unscrew the hose coupling from the pushrod tube. There's one more part here that's easy to forget. Here you have a rod sleeve that goes over the pushrod. This keeps the pushrod from splintering inside the cable. Now all I'm left with is my cable entry assembly. Remove the cable nut, protection cap. You're left with this compression fitting on the back. The 14mm wrench should unscrew it. If you have a hard time, you can use a 17mm wrench to grab onto the cable entry. Remember not to damage this rubber grommet, because there's no Retermination kit that's sold for a pushrod Retermination, so every bit of this gets reused. This is an older style of cable entry. This is going to take an important role later on, but for reference, the newer style has this portion of threads built into the cable entry. The older style comes as two separate parts. Both styles work equally well. The next thing I'm going to do is I'm going to use this special spanner tool to remove this brass locking ring from my socket insert. Use a standard pair of needle nose pliers, grab the socket insert, and gently pull it up. You might have to untwist some of these wires as you go. Once the wires are exposed, you can cut them off with just a pair of wire cutters. The next thing I want to do is remove the individual wires from the cable entry. Before I do this, I want to make it as easy as possible by shortening any remaining cable length I have. Using my needle nose pliers again, I start removing these wires one by one. There's a grounding ring inside of the cable entry that your brown wire should be attached to. If your brown wire breaks off, you might have to use a pair of needle nose pliers like this to get the ring out. I use my second special brass ring removal tool to remove the inside brass ring. This removes the thrust ring and thrust washer. The next step is to use a hammer and punch to remove the cone from the cable entry. Remove any electrical tape, Kevlar, or cable jacket that's around the cone. The next thing I want to do for my disassembly is to remove this pushrod sleeve at the end of my pushrod cable. Take my pushrod and I set it in a vise. I use a heat gun to liquefy the Loctite that's holding this on. Now that I have this removed, make sure that you don't burn yourself. Now that our cable connector is completely disassembled, it's time to clean up all these parts. Using my alcohol wipes, I'm just going to clean up any debris and dirt that's collected inside of these parts through use in the field. And then also, because this is alcohol, this is a very good sanitizing agent for my future work. Before I'm done here, I'm going to take an extra second to sanitize this section of cable that I'm going to be working with. Now that I've gotten all my cable parts cleaned and disinfected, I've removed my safety gloves because I'm getting ready to do some detailed solder work here that the gloves can sometimes hinder you. So please follow any regulations that your employer requires you to do for safety. To prep up my socket insert for reuse, first I'm going to use this pick to remove the old heat shrink that's around each one of these wires. Now that I've got all the heat shrink removed, I'm going to remove each individual wire. While you do this, take extra caution to make sure that you don't damage the outside of the socket insert. You want to angle your solder iron almost straight up and down because it's so easy to melt this outside connection. Now that I've got all the wires removed, I'm going to use some solder wick and remove all the old solder from the socket insert. Now that I've got all the old solder removed, I'm going to re-tin these cups with new solder. When you do this, you want to make extra sure that 1, you don't damage the outside wall of your socket insert, and 2, that you don't put too much solder in any one cup. As you can see here, I bridged 2 of these pins together. If this ever happens to you, use some of your solder wick, remove all the solder from both pins, and do it again. Now that we have our cable connector completely disassembled and prepped up for reassembly, the next thing we want to do is expose the fiberglass rod and the soft cable of our push rod. So I use this cable stripper to cut through this push rod hose. I'm removing approximately 25 centimeters. As you can see, I have my fiberglass exposed as well as my soft cable. If you'll notice, you can take a pair of pliers and grab this fiberglass rod, and you can push it and pull it a little bit inside of the cable. So for this next step, what we're going to want to do is take the fiberglass rod and pull it so that you have more of the fiberglass rod exposed than what its natural state is. So pull the fiberglass rod. I'm going to take my cable cutters, and for this step I want to cut the fiberglass rod, but I don't want to damage the soft cable. After you've done this, your fiberglass rod should pull back inside of the cable tubing. The next thing you want to do is use your wire cutters, and you should be able to pull on the soft cable, and as you do, it will grab the fiberglass rod and it should just barely expose it to the outside. Once you do that, you want to trim off the outside blue coating and then round off the top of your fiberglass rod. Once you have your push rod rounded off, the next thing you're going to want to do is grab your push rod sleeve and then put a couple drops of Loctite 262. The next thing I'm going to do is just grab my needle nose pliers and start to slide the rod sleeve over the top of my push rod. Once you have it started, you can take a blunt tool. I have a number 5 Allen head T-handle, and I can just use this to push it the rest of the way on. Once we have the rod sleeve set where it needs to be, the next step is going to be start reassembling the cable connection. The first thing that goes on is this nut. The next step is the final stage of our hose coupling. Make sure that the threaded end of this is going to go towards the nut because these two parts thread together. The next thing we're going to put on is the spring. If you'll notice, the spring has one end that faces towards the center of the spring and one end that faces towards the outside. The portion that faces to the outside is going to go towards the end of the cable. The next piece to go on is this black tubing for cable protection. After that, it's going to be our camera nut. Make sure that the camera nut threads are faced towards the end of the cable. The next portion to go on is the first part of our hose coupling assembly. Now, you'll see here, the threaded portion of this is approximately 1 centimeter. Now that should be about how far back the push rod sleeve end is into the cable hose. So press hard to get this started, and then once you get it started, it should self-tap, and then you'll be able to thread it the rest of the way in. I'll use a 14mm wrench to twist it the rest of the way on. Before we move on to the next step, I want to take another second to talk about the old style cable entry versus the new style cable entry. As you can see here, on the new style cable entry, this threaded portion is built into the cable entry. In the old style, it takes a separate coupling to go into the rear portion of the cable entry that's going to allow your watertight seal on the back end. For the new style of cable entry, you need to take a metric ruler and measure 75mm from the top portion of the cable coupling. Here I have it marked at 75mm, and then for the older style, you need to mark it at 80mm. We're going to be using the older style cable entry today, so I'm going to be cutting my cable at 80mm. Just using a regular razor knife, I'm going to strip off my cable jacket on the outside of this cable. You want to take extra care not to damage the Kevlar in the inside or any of the wires. going to remove this portion of the cable jacket. Now that I've stripped off the cable jacket, I'm left with the Kevlar braid. This gives the cable its pulling strength and is wrapped around the outside of the grouping of wires inside the cable. For this rubber grommet here, I'm going to go ahead and shorten it down to about an overall length of 1.5 centimeters, just to give me a little bit more room to work with inside the cable entry. Once again, if you have the newer style of cable entry, you won't need this part because it's already built into the cable entry. If you have the older style, be sure that the O-ringed portion of the threaded side is going to be towards the cable entry, towards the end of the cable. This compression fitting assembly, I'm going to go ahead and tighten it together a little bit. For this next step, I'm going to want every little bit of room I can get, so that's why I start to tighten these down a little bit. I don't want to tighten them down to where they're immovable on the cable, but you do want to give yourself as much room as possible. The cable entry goes on next. Once again, I'm going to go ahead and thread this together. And now I want to push the cable entry all the way to the back. Now that I have my cable entry on here, be sure to push it down as far as possible to give yourself as much room as you can to work with. The next piece is going to go on is this plastic cone. It has a skinny end and a larger end. The skinny end is going to go towards the cable entry. The larger end is going to go towards the end of the cable. Now, it can be a little bit of a challenge sometimes to get this cone over the Kevlar. The trick is to get as much in as you can and then start to twist the cone around like you would be screwing it on. Once you have it on, you want the cone to go over the top of your yellow cable jacket to where the top of the cone is even with the top of your cable jacket. The next step, we're going to take this Kevlar, push it back, and then push it over the top of this cone. This is going to give the cable its pulling strength and to make sure that it doesn't fall apart when you get some pulling pressure on it. Right now we have too much Kevlar. What I'm going to do is take some wire cutters and cut most of this off. Be careful when you do this not to damage any of the wires inside the Kevlar. Just going to take a small flat blade screwdriver and loosen up this Kevlar braid a little bit. As you can see, I folded over the Kevlar over the top of the cone. I'm going to take a small piece of electrical tape and tape this Kevlar down right at the base of the cone. Now that I have the Kevlar taped down around the base of the cone, I'm going to go along here with my wire cutters and cut off any extra Kevlar. You want to make this as close to the tape as you can make it, because any extra Kevlar that's hanging in the bottom has a chance of disrupting the seal or getting caught in the rubber grommet in the back, giving you a potential for water entry. Okay, now that the cone is set, we're going to take this wire wrap around the wires, remove this, get it as close to the cone as you can. I'm going to take and separate all these wires. There's a string here that's used in the manufacturing of the cable. You can remove that. Okay. Next, I'm just going to use some electrical tape to fix these wires out of my way while I'm working on the coaxial portion of the cable. Cut the length of the coax to about 3 centimeters. I highly recommend that you use this cutoff portion of coax to test with and get comfortable with before you start soldering on or cutting your coaxial that you have attached to your cable. There's a thin plastic layer on the outside of this coax. This is the first thing that's going to need to be removed. Use a normal pair of wire cutters and gently score this plastic, and it should pull off. You want to score the plastic on your cable approximately 3 millimeters above the top of the cone. Using my flat-bladed screwdriver, I want to take this braided outside coax and separate it into 2 separate strands. Remove one of the strands and take the other and wrap it around the inner insulator of your coax. It's important that you don't get too much bulk when you're doing this. The smaller that you can make your connections at this stage, the easier it will be for later steps. Of the remaining coaxial cable, I want to cut this off so I have approximately 1 centimeter of center conductor left. And of that, I'm going to strip off approximately half to expose the copper of the center conductor. Once again, I strongly recommend that you practice this step on the removed portion of coaxial cable before you move on to the cable that's still connected. I'm going to remove my center conductor to where I only have about 1 millimeter exposed. Okay, now it's time to tin the connections of our coaxial cable. Like everything else with a coaxial cable, I recommend that you practice this on the scrap piece before you move on to the actual cable. When you're tinning the outside portion of the coaxial conductor, it's very important that you don't leave your soldering iron on for too long, because if you do, you can fuse the inner and outer conductor of the coax and you'll get no video or a very degraded video. After you've done this step, I highly recommend you check these two connections with an ohm meter to make sure that the value is no less than 75 ohms. The next step, I'm going to remove this little electrical tape. I'm going to pull up my cable entry, give it a little pull, and you should feel it seat, the cone seat down inside the cable entry. I'm going to use this as a gauge to see exactly how much wire length I need. I'm going to remove any excess. I like to leave myself about 2 centimeters of extra cable length beyond the end of the cable entry. Now I'm just going to pull this back down to its original position to give me more room to work with. Once again, I'm going to just tape these out of the way while I'm working on the coaxial connection. Of the wires that we just cut off, we're going to reuse a portion of them. First, take the white and black wire. We're going to use these as our inner and outer conductors of our coaxial cable. When I strip these wires, I want to leave approximately 1 millimeter of exposed wire to solder to. I use the white for the center conductor and the black for the outer conductor. When you attach these wires, you want to be sure that both the wires are going to be facing vertically and not that any wire is going to be sticking out like this. After you make these connections, use some heat shrink to insulate the connections so they don't short to anything. Now that the coaxial connections are done, free up your other wires so you can work with those. And you want to grab your thrust washer and place this over the top of all the wires, including the coaxial connection. The thrust washer has a conical side to it and a flat side. The conical side is going to go towards the cone. The next step is we're going to take the black and violet wire and the white and orange wire. These pairs of wires are going to be fused at the end of the cable. Before you attempt to strip these wires back, I highly recommend that you do so on a scrap piece of wire as to avoid cutting the wires too short. I twisted the two wires together, and now I'm going to fuse them with a solder joint just after the wire insulation. After you have your solder joints made, take and cut off any extra wire with just some wire cutters. Of the wires that we cut off and saved earlier, we're going to use the violet wire to attach to the black and violet wire connection, and the orange wire to connect to the white and orange wire connection. We're going to insulate our solder joints with some heat shrink. And take all of our wires and cut them all to the same length. Now you can get rid of any extra wire. The next step is to take the thrust ring, put it over the top of all the wires, and it should lay right on top of the thrust washer. Now I'm going to strip and tin all the wires. Unlike a mainline connection, I don't want any excess solder on the end of my wire connections when I tin them. I'm stripping these wires to have just over 1 millimeter of wire exposed. Now that you've got all your wires tinned, it's time to connect your wires to your socket insert. You want to start with the middle and work your way on the outside. All of these cups are numbered on the outside of the cup, so there shouldn't be any confusion about which wire is which. For heat shrink, I'm using a very small, stiff heat shrink. It has an inside diameter of 1 millimeter. Once again, when you're soldering these connections, you want to keep your soldering iron almost vertical and make sure that you don't want to damage any of this outside connection here. After each one of these solder connections, you want to test the strength of your connection by pulling on the wire, giving it a few different tugs, just to make sure that it's not going to break free. Because these pins are so tight together, you want to make sure that you slide down your heat shrink every time to avoid bridging any pins that you've already soldered to. With a pair of pliers, solder the hooked end of the grounding ring to the end of your brown wire. Now that you have all your solder connections done, now it's time to pull up your cable entry. Give it a little pull. You should feel the cone seat down inside of the cable entry. I'm going to take a pair of electrician's needle nose pliers here, and I'm going to use these to screw in the thrust ring into the cable entry. Okay, once you have that done, any of this extra wire up here is going to get twisted around and tucked into the cable entry. That's why you wanted to make extra sure that all of your solder connections are very strong. First, take our ground ring, wrap it around all of the wires that are going to the socket insert, wrap it around the brown wire, and then use the needle nose pliers to push the ground ring down to the bottom of the cable entry, and there will be a groove that's cut out that this grounding ring sits in. After you have your thrust ring tightened down and your grounding ring where it needs to be, take this brown wire and push it down to the bottom. Next, note that the socket insert has a hole right above the plug connection of it. This hole needs to line up perfectly with the alignment pin that's on your cable entry. I'm going to take my socket insert and start twisting these wires around as I push them in. Line up my hole with my alignment pin, and the socket insert should seat all the way down. After you have your socket insert pushed into your cable entry, take your threaded retaining ring and screw down your socket insert to allow no movement. Before you tighten down your compression fitting and seal the back of your cable entry, first you want to make sure that this aligning groove here on your hose coupling and the aligning groove on your cable entry are 180 degrees out from one another. Once that's done, go ahead and tighten down your compression fitting. Use a 17mm wrench to hold on my cable entry while I tighten down this nut back here. It's going to seal the cable with that rubber grommet. Once you see the rubber grommet start to push outside of the nut, it's tight enough. Now that I've got the back of my cable entry sealed, I'm going to take the other half of my hose coupling, put this together, now that I have the hose coupling assembled, I'll pull up my camera nut, my push rod spring. Notice that the alignment groove on the cable entry is going to seat the front part of my push rod spring, and the alignment groove on the hose coupling is going to seat the rear part of my push rod spring. I'm going to finish screwing together my hose coupling assembly. The last piece to go on is this hose nut that's going to lock the push rod spring into place. Congratulations, you've just completed a push rod retermination. I'm Josh Taylor, Master Service Technician with Rapid View Service. Thank you for watching Rapid View U.